So we move to our next talk. I remind you that if you want to ask any questions, either from the room or remotely, you can go to onlinequestions.org, event 20147, and ask questions there or vote for questions that have already been asked. Our next talk is about GStreamer on the Magic Leap one. Please welcome Xavier.
Hi, so I'm Xavier, working at Collabora. Today I'm presenting GStreamer, so the work I've done last year to port GStreamer on a Magic Leap 1 device, showing it there. So those are augmented reality glasses. So the Magic Leap is building those glasses and they are selling it online. Augmented reality is glasses you can see through. So you see your own the real world environment, and you can add virtual elements inside your living room or anywhere you are. And for example, you can add a TV screen on the wall in your living room, and when you can watch TV like that with the glasses. That's not the same thing as VR, because virtual reality is a completely opaque device, so you can't see anything from the real world. You see only virtual environment, and so if you walk, you just walk into the wall, and that's not happening with AR. Magic Leap has 3 elements. So first you have the glasses, and then the glasses is the light wear, and the light pack is connected with a cable. You cannot remove the cable, so that the light pack is the computer itself, doing all the CPU and GPU, and so all the stuff I'm going to code is going to run on the small round computer there. And of course, you have a controller to manipulate virtual objects. So a bit of specs. The light pack is where the OS is running. It's an NVIDIA Tegra X2 chipset with 6 core, and it's ARM64. The OS is called LuminOS. It's based on Android, but there is no Java. So basically, as far as I know, they are doing that to get vendor support from NVIDIA probably. And the media stack is what I really concentrate on, and it is stage right from Android. There is a public SDK. It has a complete C API for everything. So on Android, you have Java API to write Java code, but they write everything in C for the middleware. And you have C++ API for all the UI toolkits and the more advanced features. Yeah, they have for the audio side, they have custom APIs. That's something I've never seen on Android, so they wrote it from scratch. And they also wrote from scratch their own build system called Mabu, because we don't have enough build system yet. The project I've been working on with Collabora was sponsored by Mozilla. Mozilla has their new browser called Servo. Servo is written in Rust. It's a brand new browser, and they want to port it to various VR and AR devices. And they had an issue because they ported on Magic Leap device, but they cannot render any media. So the video and audio was not working because they are using GStreamer on desktop to play all the media, but they couldn't port Magic Leap, GStreamer to Magic Leap device. So they contacted us at Collabora, and we helped them to port it. So yeah, Servo is written in Rust. So the build system is Cargo, so yet another build system. They have various Python scripts on top of Cargo to drive the build. Yeah, so Alan Jeffrey already did, before contacting me, they already did all the porting of Servo to Magic Leap, except for the multimedia part. So I won't be speaking about that journey from them. They have a blog post already telling all the story for that side, concentrating on the multimedia part here. Yeah, so for the video, they are using an AppSync. That means that they don't let GStreamer rendering the video. They get the frames out of GStreamer and they render them themselves in their application. And for the audio, they let, on the opposite side, and for the audio, they let GStreamer do everything itself. So GStreamer is supposed to detect the platform and plug the right audio sync. Of course, there is no audio sync for Magic Leap yet. So GStreamer, that's a multimedia framework written in C. They had an Auto Tools build system. Thankfully, it's removed now, and it's fully Mason build system now. So that's the third build system in my presentation. Yeah, so GStreamer already has support for Android, but they are using the Java API through GNI. So yeah, GStreamer is like, for people that don't know GStreamer, it's like a pipeline when you have elements you can connect together to write your rendering. So the first step is to actually build GStreamer using the SDK. There's two ways possible. Either you use GST build or you use Cerbero. GST builds use Mason and has many sub-projects to build every single dependency you can, at least the art dependency, but there are some optional dependency that it cannot build yet. On the other side, Cerbero, they can build every possible dependency with their own build system, and but it's more complicated and less integrated. So since I'm a Mason developer, I decided to go with the GST build, a new way of doing things, and I've not been using Cerbero for this work, because one of the main reasons is that on Magic Leap I didn't need any external dependency. So my project was really like small scope, so I don't have to depend on any Auto Tools library, external libraries, etc. So I decided to go with GST build and use only Mason for that. Yeah. So the first thing to do is write a cross file using because there is a toolchain in the Magic Leap SDK you can download. There is a toolchain there. You write a cross file, compile, and hopefully it works, right? So the cross file is something like that, a bit simplified here. But yeah, so you define you pretend it's Android, because GStreamer has many special cases for Android, and you want to use those special cases. You define that it's ARM64 architecture. And yeah, like you see here, a little bit trick I did. I don't write the full path to all those binaries. I've got a variable there, Magic Leap SDK. At the beginning, I was using this file that was actually processed by SED, just to replace all the variables before passing that to Mason. But spoiler alert, I have a merge request on Mason to support that kind of syntax inside Mason itself. So you don't have to repeat all the full path where you installed your toolchain anymore. Yeah, so the first issue I went when building GStreamer is that glib depends on iconv, And the SDK from Magic Leap actually has iconv.h, the header, but surprisingly, they don't have the implementation. Usually the implementation comes from the libc, but no symbols there. Don't know why. So I had to build iconv from the GNU project. Of course, that's yet another build system, auto tools now, sad face. But I can handle it. Configure, make install, all the good stuff, and it works. It builds. You can install that in the path somewhere, and you can add the -L and -I flags in your Maison cross file to pick the iconv implementation you just built. Next step, so with that iconv issue fixed, you can actually now build the full GStreamer hit pass. And the problem is it does it too well. You have many, like more than 100 plugins built, but you don't care about them. One trick I use, it's a really nice feature you have in Maison, is you can disable all the features altogether with the auto features equal disabled. That means that with GST builds, if you do that, it will disable every single plugin and build really the minimum, the lib GStreamer core and nothing else. And then you can add yourself the exact plugins you want to enable, and it will build just that. So you save a lot of time and a lot of memory, because the full build takes like almost 200 megabytes for the application you want to ship. But if you enable only the few things, it's down to less than 10 megabytes. Yes, so there are a few options you have to pass. You want to enable GL, of course. The GL support in GStreamer. On Magic Leap device, they have GL ES2 on EGL platform. And yeah, the Windows system, I fake it to Android because Android is already implemented in GStreamer, and it's really similar on Magic Leap. Yeah, another trick again, I had that idea when working on this project is when GStreamer builds itself, you get every plugin as a separate library. And that's not really convenient if you want to package that in your application, because you have many files to compile, to copy inside your package. And Magic Leap device was actually not really happy with that, because they don't let you have any DL open on any shared object outside the binary folder. So you cannot split. Like on distribution, you have a GStreamer-1.0 subdirectory in your /lib, and so GStreamer will only look for plugins there. But you cannot do that trick on Magic Leap because they have security rules that forbid that. So you cannot DL open those files. So one trick I've done is if you build, that's a patch still waiting for review on GitLab if someone from GStreamer developers want to give it a try. If you build GStreamer with default library equals static, it will build every plugin as a static plugin, and at the end, there's added a bit of code in their Maison file that bring all those static libraries, build them into a single libGStreamer full shared library. And it also generates a small C file that registers all the plugins you just built. So you have a single function to call to initialize all the static plugins, and you can use one single shared library, and you don't have to manage all those plugins and DL open anymore. You just directly link to that library. So now that we have GStreamer built, a small version of GStreamer with one single library, the next step is to build that into a Magic Leap application package. So as I said, that's the Mabu build system, custom from Magic Leap. They've wrote that. I don't think there is anyone else using that. I think they've wrote that themselves. Luckily, it's pretty easy to use. You define the include path you want. So I gave them the path where I installed my GStreamer, glib, and etc. Everything that GST builds, and you can just copy some files. So that's the data list. Those files are just copy inside the application package. So as you see, there is only 2 files to copy: the GStreamer full shared library and that icon-v shared library, because they don't have it. Yeah, as I said, you just have in your main application, you just have to call GST-init and that new function GST-init static plugins. That new function is implemented in the GStreamer full shared library. And that's it. You can actually already, with that, you can already run GStreamer on your device, but you have no codecs. Yeah, so for the codecs part, of course, you want to use the codecs from the platform. You don't want to use software decoders. So if you look inside the public SDK, you will find media codec and media codec lists. And if you open them, it's really surprising. You actually have 1-for-1 exactly the same API as the Android Java API. They just translated it in a C, and it's exactly the same API. So that's actually a good thing for me, because GStreamer already has that Android Media Codec EMC plugin working. The only issue with that is that so GStreamer used the Java API, so I had to move all those GNI codes, separate it behind the wrapper layer, and implement that wrapper layer with the Magic Leap API. So you can, at build time, select if you are building it for Magic Leap or for Android. And all the rest of the code is exactly the same. So that's a really good way of sharing that code. And those patches are already merged in GStreamer master. So that's coming soon in 1.18. Yeah, so yeah, and now that's an extra option you have to pass to Maven to enable in GST plugins bad the Magic Leap option that will select that new implementation for the codecs. Video sync now. So as I said, the codecs produce GL texture external OES, but server was expecting texture 2D. So I did not work on that, but Mozilla had to modify their application to actually support both formats for the textures, because so they have their appsing that get those textures, those GL textures, and they had to modify their code to support that. To render that, you actually write a Magic Leap application with a planar resource object. That's like a widget that exposes you an EGL context. So you can draw with yourself with the EGL API on that surface. Yeah, so you have to handle the EGL context sharing with GStreamer, because GStreamer has its own context for the decoder, and so the decoder produces a texture with its own context, but you have to tell GStreamer about your application context. So GStreamer can share those both contexts, so you can use the texture inside the Sadly, you cannot use GL image sync directly. I tried to use it, but there is some slight missing API there because they don't expose the native window. I'm pretty sure inside that planar resources, there must be a native window, but the API don't give you a pointer to it, so you cannot pass. Usually, you would pass that native window down to GL image sync, and the sync will do all the rendering for you. But since you don't have that pointer, you cannot do that. So you must use that app sync and do the rendering yourself. A bit frustrating because it's really missing just one single getter just to get there. Maybe they will add it later. Audio sync part. They have two completely different objects, header files, mlaudio.h and audionode.h. One is C, low-level API, and the other one is C++, high-level API. The reason for that is there are two ways for rendering audio on Magic Leap device. The device itself has stereo speakers right onto your ears. But since the source of the audio is somewhere in the 3D world, either you can just play the audio plainly as a stereo audio, but you cannot really know from where the audio comes. And that's the C API, what the C API implements. But the C++ API is smarter because that's actually a widget that you can plug inside your UI. It's an invisible widget, but that tells the audio stream exactly from where in the space the audio comes. And that widget is capable of modifying the audio you send to sound like if it comes from that position. So if there is a video wall here and you turn your head, you hear the audio coming from there. It's really impressive, and that makes all the difference for the immersion you have. Yeah, so if you look at those headers, it's weird because it's exactly the same API implemented twice, one in C and one in C++. So it's exactly the same calls. So I've wrote in GStreamer a wrapper again, so you can pick one of them at runtime. Yeah, so if you want to use the 3D spatial audio, you have to tell to GStreamer exactly. You have to pass that audio node object, C++ object, down to GStreamer, so GStreamer can use that object instead of using the plain C API. So I've wrote a new element in GStreamer called ML Audio or ML Audio Sync, and when that audio sync wants to render audio, it's going to pop a message on the bus, and the application is supposed to reply to that message with the pointer to that audio node object. And if you do that, it's going to use that C++ API, and you get really nice spatial audio. Upstreaming. So thanks to Mozilla for sponsoring all that work. And they even sponsored the upstreaming of all that work. So everything is already merged. So you can use that with GStreamer Master right away. Thanks to Olivier Kretz, who did all the review. You can also find a standalone applications demo at that URL. And that demo is not using Servo, so it's just a plain video player you can try. And we have a demo at IBC showing that. Yeah, coming that next GStreamer release. And now the demo, because GStreamer is always tested with video testers. As you can see, Magic Leap is capable of detecting the surfaces and cut the video at the right place. There we go. Any question?
Thank you. We have no question online. We have a question from the remotely, the people who attend remotely, asking if we can put the slides in full screen. It's difficult to do it all the time because we want to see you. We try, but your slides are downloadable from the website, from the FOSDEM website, because we're well behaved.
Exactly.
That's good. All speakers should do that. Any question from the floor? We can take one question. Yes, please.
You mentioned that there was one getter missing in one of your dependencies.
Yeah.
It would have made things much easier. Why did you make like a pull request for just adding these getters to the...
Because the Magically platform is closed source. Sorry. So the question is why I don't just make a pull request to add the getter, the missing getter for to be able to use GL image sync. The reason is that the platform is closed source, so I cannot just do a pull request. They have an issue tracker, so I already, actually some of the APIs I'm using right now were missing, so I did some requests to get them. But yeah, you're right that I could request that API as well. I don't think I reported that issue yet.
Very quickly, is this augmented reality helmet widely available?
Widely not, but I think you can buy it in the US only, just for a few $1,000. So anyone can buy it.
Thank you, Xavier.